Hey everyone, thanks for bearing with us with the 5 o'clock talk today. You all look very awake. Hopefully that's not going to change over the next 40 minutes. So we're going to be talking about a couple of things. One is this concept of stream as the system of record and how that gets applied to some of the problems in healthcare data architecture. So obligatory about us, I'll let Brad introduce himself.
Yeah, my name is Brad Anderson. I run the development teams for data management at Liaison. Liaison's a Atlanta-based company. We have 7,000 customers, 46 countries. We do data management and data integration work, and I'm also on the board of a company called On Call. It's an in-house for the elderly, kind of a data hub that captures all the data from your sensors and sends that back to a central location for monitoring and such. And before that, I was at MapR and co-founded a couple of startups. So, Will?
All right. And I'm Will. I'm on the product management team at MapR. For those of you that don't know us, we're a converged data platform company. We do distributed storage, database, streaming, and all the analytics tools on top, like Spark and Apache Drill. Before that, my background was in cloud and networking at Cisco. So what we're going to do today, first, I'm going to introduce the technical concept of what it is to have a stream system of record, and then kick it over to Brad to talk about how this and other technologies and architectural choices help solve a lot of the problems that he was having with healthcare data. So, starting out, first off, let's define stream, and I'm sure this isn't the first talk that you guys have been to here or before that talked about streams, so let's just think about this as synchronizing terminology. So, for the purposes of this talk, a stream is an unbounded sequence of events that go from producers to consumers. So producers are any applications out there that either create or detect events, and consumers are anything that either needs to process or store those events, and those, of course, go through this object called a stream. Diving a little bit deeper into that, think of a stream as something like a queue. So in this case, we see several people lined up in a queue. There's a front of the queue, front of the line. Unlike a queue, with a stream, events are persisted even after they're processed. So you see here, more events were added to the queue, the line moved, but events stayed in the queue, they're persisted. And they're persisted for good reasons here. They're persisted because there could be multiple consumers that want access to that data, or you could want to reprocess data, or you could just want to hold on to it for long-term storage. Can you think of another area in everyday life where it seems like you stand in a queue forever? I can. More on that later. So, now that we've taken this concept of a generic stream, what does that have to do with the database? What does this have to do with a system of record? So imagine a use case for a stream where every event had something to do with a change made to a database. So every event is an incremental change to a database. So here we have a simple DMV database structure set. Now let's walk through some of these events. So each event is some change to that database. So in this case, my record for the DMV, I change my city to Mountain View. So when I do that, the view in the database changes me. I live in Mountain View. Now Brad comes along with his record. He registers with the DMV. City is Atlanta. So he goes into the database there too. So now we see a relationship between these events and the actual materialized view of those events in the database. Now, Brad has one of Elon Musk's electric vehicles, and one day he was running late for work, so he put the gas pedal down, or the battery pedal down.
That's better. That's better.
And he got some red lights in the rear view mirror, They wrote him up, and he got some points on his license. So now the next event is points got added to his license by Officer 1213. So now the materialized view is he has points on his license. And I decided to buy a house, move to San Jose, so now my city has to change to San Jose. So now, with this example, you can see the relationship between the events, the changes to the table, and the materialized view of that database table. So we start to see, some people call this the duality of streams and tables. So now starting to apply this to some of the data problems out there. So the first thing to realize is streams are not a replacement for databases. Even databases are not replacement for databases. Look how many there are, and this isn't even a complete list of all the kinds of databases there are out there. Each one is optimized for some sort of pattern of read patterns, or sometimes you might want to do a graph query or a search or something like that. So the first challenge people often have with implementing these data systems is, what if you need to have the same logical data set present in multiple different types of databases for different types of queries coming in? You need some sort of system of record for that. So the best approach that we've thought of is to have this stream act as the distribution point for all of these different databases. So every time you want to make a change to your data set, it becomes an event on the stream, just like with the slide before, and then it funnels out to all the individual databases because these databases act as consumers of that stream. And now they're in sync, all in real time, and you can query any of these for the thing that database is best at serving updates for. That's one use case for streams. There's several other use cases for modeling databases with streams. So here's, again, the same example of our stream. So one thing you may want to use this for is lineage information to ask questions like, or answer questions like, how did Brad's points get so high on his license? Maybe he wants to take it to court. Auditing who added the points to his license. Because there's extra metadata in each of these events on the stream, you can really introspect more into how things got to be the way they were. History or rewind. So where did I used to live? So using this concept of having the full stream represent the full history of your database, you can do a time machine fast forward, well, maybe not fast forward, but you can do a time machine rewind and actually see what the status of the database was at April of last year. And that's useful for lots of different things. And the last one is the integrity. How can I be sure, or can I trust that this data hasn't been tampered with? And I'll give you the answer to that one right now, which is yes, because streams are by definition immutable. So you can use these to really feel confident that the data that you're seeing is trustable. So lots of different use cases for having streams model your databases. Now we get back to the title of the talk, which is Stream as the System of Record. So out of these two views, which makes the most sense to actually consider your system of record or your authoritative source of what your data actually is? And I think the simplest way to answer this question is to ask another question, which is, which of these two can be used to reconstruct the other? It's fairly obvious you can use the historical incremental changes to the database to recreate the database itself, but you can't recreate the historical stream from whatever the status of the database is today. So that's what really brings us to this concept of stream as a system of record. So by now, you're probably sitting in your chair burning, wanting to know how you actually implement this in your own environment. So there's just a few things that you need out of your underlying system to make this stuff work. So one is you need a system that's able to infinitely persist events, because a stream system of record is no good to you if you can only hold on to a minute, an hour, a day worth of events. You need all of the events, or it's not your system of record. You need a way to query that infinitely persisted history of events to answer all of the auditing lineage questions that we brought up earlier, or else it has limited value. And the last piece is you need an integrated security model across your stream and your databases to make it trustable from end to end. MapR does all this. With that, I'll toss it to Brad and show how this actually has use in a healthcare environment.
Where's the best place that you point this?
I'm not sure. I think you just have to really jam it.
Okay. So I do want to reintroduce the Liaison Alloy platform. Excuse me. I do live near headquarters in Atlanta, and I actually have 0 points on my license. Thank you very much. Will's slides were very illustrative, but not true. So for about 16 years now, Liaison has been doing B2B integration, and those of you in this market know that it's not terribly exciting, and it's also quite commoditized. This is what we've done. We've taken data in from either a trading partner or the company itself. We've transformed it in a way that the target would like to see it, and we've gone ahead and shipped it out. This is B2B integration, EDI data. Remember all of that before XML. Some of the trading partners want XML, some of them want EDI, some of them want JSON. We handle all of that. What they started asking us to do is hold on to the data and give us some insights. What can we do with this data? Because it's already flowing through the Liaison pipes. So the first thing we did was we started mastering data. And again, I wouldn't call us a full master data management system. Those systems have hundreds of features. We're just doing 7 or 8 functions of mastering data, for instance, patient data or product data, and deduplicating them, harmonizing them, relating them to other data sets, and so on. And the questions kept coming. Can you also do this with the data that is flowing through? Can we have a sandbox to explore certain things, what-if scenarios? Can we do full-on analytics? And so the data management platform, the bottom there, is the new product line. And both of these large, the integration and data management components make up Alloy. And we do have a healthcare vertical, and because the talk is about healthcare, I'll concentrate there, but we do have customers in, we have Boeing and Merck Pharmaceuticals and other paper industry companies, International Paper and so on. So we do a lot of supply chain data, sensor data, and such, but for now I'll talk about 2 use cases that we do. The first one here is a state health information exchange for Georgia, and we have a couple of other ones. The data comes from provider organizations, hospitals, and doctors' offices, and it flows into Alloy Health Exchange. There are clinical data viewers, there's some reporting and analytics that might go to federal, and then there's an exchange over here on the right where other systems like ours are also contributing data to the state of Georgia. So again, this is a lot of data movement, but all of the medical records from the doctor's offices and hospitals and potentially all of the lab orders and so on are stored in Alloy Health here. And you can do queries like what they're being asked to do, population health, right? What are the outcomes in the entire state on diabetes? And are there doctors that are doing this better than others? You have to hold on to all of the data to be able to answer that over time. Here's another use case. This product is called EMR Link. And again, we go into the EMR systems at the doctor's offices and hospitals. And this is a marketing slide. I didn't really want that, but I just grabbed it. So the lab orders come into Alloy and they're sent to the labs. So then the patient goes over to the lab, gets blood drawn, gets some radiology, and those results come back, and they need to be matched up with the orders. And oftentimes, the blood work comes back in pieces. There's a CBC, there's a hepatic screen, there's metabolic panels. They come in at different times because the tests are concluded at different times, and radiology might be late. And so we have to wait until the entire order is filled, and then we'll inject it back into the doctor's EMR system so they can take a look and continue the treatment for the customer. So those are the 2 use cases. We have others. There are a couple of regulatory things that are happening in the EU where they'd like to track the entire supply chain of a drug from conception, design, through clinical trials, through distribution, and so on. All of these use cases have to sit in a compliant environment, right? We've chosen healthcare as an environment, as an industry we'd like to service. We've chosen financial services, and it brings a massive pain in the ass to the Alloy platform. So PCI is payment card industry, and DSS is the security framework. And so we have a product that tokenizes credit cards. So the entire Alloy platform is PCI compliant. SOC 2 is a data center certification you can get where you've proven to auditors that all of your practices are sound and secure enough, and the separation of concerns is there, that you get that certification. And then HIPAA was a 2007 piece of legislation, followed on by HITECH, which was kind of giving that a little bit more teeth. And then the really big pain in the ass is the FDA one down in the lower left here. This is, if you're going to accept data from a medical device, like some of the sensors in your hospital rooms, the medical device certification has to also apply to where the data goes. So you have to treat the entire data platform as a service, as a medical device. And so that's the 21 CFR Part 11 certification. So again, this is a pain in the ass. This is not me going into compliance meetings, although it's fairly close. This is Fred, and this is one of the little nuggets of information that really had us scratching our heads. Regulations say that you have to obfuscate the zip code of anybody over 85. So think about a patient record, right? You have to protect their social security number, their date of birth, and other things that might identify them, right? If you have a US-based zip code and somebody 85 or more in that zip code, that is identifying enough, because you're looking at this medical record of somebody who's 85 in 94135, whatever, and you say, oh, I know, that's Fred. Wow, look at Fred's glucose numbers. That's terrible, right? You've identified Fred, right? So just these immense amount of business rules that you have to do to become compliant, to prove to your auditors that you are compliant, is it's quite a task. The next couple slides are kind of a why now. Why are these things bubbling up now, and why do we need platforms like this? This is a Forbes article. I think the slides are available later, and the link down there will take you to the Forbes article. This is the wall of shame for 2015 for healthcare breaches. And as you heard in the keynote, the 2016 is not off to a great start and could be even worse. But you see 1, 2, 3, 4 of them are Blue Cross Blue Shield related. And so I think I was in the top one there, and I was also in the Target one, which we'll talk about later. But yeah, I get free credit protection for the rest of my life, I think. I've been in so many of these, the Home Depot one. So let's talk about the financial impact, right? Let alone the risk of an executive going to jail for some of these things. That's also a nice motivator. But if you look at the fourth quarter profits from Target right after their breach, that's a negative number, $440 million. And the Anthem one is 8 to 16 billion. They don't quite know yet of what that's going to cost. But in that Forbes article, you'll also notice that they had an insurance policy for breaches, so they're not going to be paying all of that themselves, which I thought was very interesting. But these things are real and are happening at an alarming rate. On the other side, Will talked about the relational database not being the only tool that we have now, right? There are conferences about Hadoop. There are conferences about Kafka and all these other new databases, right? We have tools now that we can use from these companies, and there are many more. The ecosystem around Hadoop is massive. As you know, you're at that conference. Kafka, HBase, there are graph databases like Arango and Titan that you can use. And what you're doing is you're using this tool because you don't have to always cram your use case into a relational database. Anybody done a graph database like a graph traversal algorithm in a relational database? I tried a few years ago, and I actually got a message back from Oracle saying the estimated time to complete this query was 14.3 years. So right now we're in a time where you can use the most appropriate tool for the shape of your data and for the shape of your queries. And you want to do that, right? But what do you think the bottom companies there cared about compliance, about operating in regulated industries? They built these tools for themselves. So there was not a lot of thought around the questions that auditors are asking, right? You just have this this gap. There's another talk that I give where I talk about the business problems and operating in a regulated industry and these fantastic tools, and you have to mind the gap, right? Everybody has to do like a London Underground mind the gap talk at some point in their lives. They're great. So let's talk about the promised land, right? And this is a little bit more elaborate view of what Will was talking about earlier. The magic here is at the bottom. You have raw data coming in, and you have to maybe protect the zip code and Fred's social security number and his age and so on. But then the messages go on as they arrived at your system, and they become the system of record, and anything can consume them if they have the proper entitlements and permissions. So you do a little bit of pre-processing because, as Will said, this is persisted. The immutable log is persisted. So you can't put anything on disk if it's sensitive, unless you've obfuscated it, right? Protected it like a credit card or all the HIPAA data, the personally identifying information. So then you have different listeners, and you have different listeners or consumers based on the use case. If you're going to do a patient matching use case where you have John Smith and Jonathan Smith, and you don't quite know if they're the same person, you might want to load all that data into the search engine and the graph, because those two tools and the queries that they provide you will tell you, and also with some contextual data, like both of these records that you're not quite sure if they're the same person, they go to the same doctor. And the doctor prescribes the same drug, and the drug is prescribed to both of them at the same dosage. So instead of John Smith and Jonathan Smith, maybe 20% confidence being the same person, if I know that extra contextual data, because it's also loaded in the graph, I now am at about 95% sure that they're the same. So you're loading the data off of the log into the most appropriate data system. And you see the ... all the way to the right there? I mean, there's a kid in Russia right now hacking on something that he's going to release to the open source world, and I'm pretty sure I'm going to want to use it because I'm going to have customers that want to use whatever he makes. All we're going to do is replay the messages from the beginning of time and load them into this new system. And we're right there with then. So this is a just-in-time use case delivery system, right? Depending on what you have to do and what those microservices have to consume, you put the data into these different systems here, and then the microservices themselves that do interesting things like patient matching or the lab to orders to results matching, and then stick it back into the doctor's office system. All of those are more business facing, and then there are APIs and applications there. They need the data to be in the best tool for the job, right? So you can see compliance auditors. These people are not fun at a party, believe me, but they do have smiley faces at times. When they can see data recreated from, essentially everything that's ever happened to that piece of data, right? The first message in there was first name Brad, last name Anderson. No points. The second message in was Will, and the third message in was, oh, actually my name is Bradley, first name Bradley, right? We didn't overwrite it, we just put another message onto the end of this. So the auditors can look at that and say, oh, they never delete data, so we can always trace it. We actually, you see the workflows there? We use this same methodology to track the code or the configuration in the workflows. Those are versioned on an immutable log as well. So what was the workflow operating on the data 2.5 years ago? This does make auditors smile. Whatever. It does. So you can see the history in this document log over here as well. For this one key, all the values, say the first row there is Brad, and all the values that I've ever had added onto the log are there. So why they're excited about this? Hey. So the auditor smiley faces come from data lineage. They come from audit logging, who has written to or updated, tried to update, even read. If you want, some industries need to know who read every record and every field of every record. And if you really want that level of audit logging, we can turn it on, and there's a cost to it. But, and then the other thing that they like is when data is flowing to all these systems, because you have a Kafka and a HBase and a Hadoop and a graph database, the data in transit has to be encrypted. And then when you put something on disk or materialize it into one of the views, it has to be put down in encrypted as well. The other thing that we like about this is, and we'll talk a little bit about this later, is replication for disaster recovery. So you can, it's not a MapR commercial, but with files and HBase like tables in MapR tables, you can actually mirror those over to another data center. For us in Alloy, it's Atlanta to Phoenix, and it's London to Helsinki. And Brexit's kind of pissing me off because now there's some medical records we cannot move out of the EU. So now we're going to have to probably go to Amsterdam and Helsinki to back things up and have a disaster recovery copy of the data, and then the UK will be out on their own. I think we have a couple years for that though. So, okay. So and I know this is about streaming and about big data, but the non-streaming and non-big data things that you have to do are also riveting. The software development lifecycle has to be documented and agreed upon and signed off on, and the system hardening and separation of concerns, right? Usually DevOps is a good thing, but Dev versus Ops in this case is you can't have developers have access to production because they can put some code in there that will reveal the credit cards or mine the healthcare data, which evidently is becoming more valuable than credit card data. They're getting more for the latest breach. There's 600 and some thousand healthcare records on the market now. I just saw this yesterday. They're fetching higher dollars than credit card numbers now. So, and just patch management and a lot of boring things. So compliance is hard, and you have to make sure you get kind of the blocking and tackling on the left from your big data systems. And if it's not there, you have to build it in with, and streams help hugely there. And you also have to do these kind of really boring things on the right as well. And it's a lot about process and procedure as well as your technology. So the solution we used, the design and architecture, which is not ours. It's Datomic has had portions of this immutable log message. And then also Jay Krebs and Martin Kleppman from Confluent and the makers of, originally at LinkedIn, of Kafka, also have had this. And if you get a chance, go look at 2014 Martin Kleppman's talk on turning the database inside out, something along those lines. It was very formative for us. So it's just the idea of the streams being the system of record and then moving the data into these materialized views as needed. So MapR solved a lot of other issues for us. The unified security was huge because we were already loading files into MapRFS and tables. The columnar tables, you saw the key value store with the lineage in it as well per record. And we're mirroring those over, right? Replication, data center to data center. But we got, so when we started off with Kafka, we got the 082 no security model. And our auditors didn't really like that all that much. And we knew we had a little bit of time to kind of remediate that massive gap in our technology infrastructure. So walking into MapR streams, you get the same unified model that you get with your files and your tables. So that was huge. You get the replication. We were able to get rid of our Kafka cluster and add those nodes to our MapR cluster, which was a nice bonus, right? And anytime you can simplify your operations and have fewer things for those guys to manage, they love you and take you out for beers. Multi-tenancy also, Kafka has some issues around the number of topics you can put into a stream. Actually, a stream would be equivalent to an entire Kafka cluster. So if you kind of max out the number of topics, you need another Kafka cluster. And we knew we were going to have a lot of these because every use case from every customer is going to spin up 2, 3, 4 topics, and consumers and producers are going to be throwing data and pulling data and processing. So with some of the technology magic that MapR does under the covers, you have essentially unlimited topics to have these messages flowing into and consumers pulling off of. So some of the things were solved by MapR. A lot of them were solved by the overall design. Okay, just a couple more slides to show you that this system is real and working. This is one of our workflow editors and running through a kind of a grab the data, read the dates. If the dates are not compliant, you kind of clean them up. You might do a match and merge and then write it to somewhere else. And what would happen is this, this first workflow activity here on the left will go ahead and attach to one of the streams, and that's its data source. So the preprocessor and the writers to the producers to the stream know that this will always be running. And this is one of the things that's also versioned, and so it'll just blast here and finally end up in a materialized view that is useful for some application to query in some way that gives insight. One of the things we have, patient registries we have the American Joint Replacement Registry. Every knee, hip, shoulder, whatever they can replace in you is in this database. And all of the medical records and the manufacturers and the part numbers, all of those are in this database. And so researchers come and research this data to figure out if the part is wearing out at 15 years instead of 20 like it was promised, and so on, and they increase the quality. But you also have blood and marrow transplant. You have like a donor and a recipient, and all the data is being captured from those. And when the data hits, it flows through a number of these workflows. Let me also show you the data model designer, where you have the patient data model. So Alloy has the notion of very flexible data models. You can put a data model onto a stream and have it flow through a workflow and land somewhere, and you can put an entirely different data model on the same stream and flow it to another materialized view. So you have this notion of patient and encounters and glucose and nurses' notes and doctors' notes and blood pressure and so on. And this could be completely different for healthcare organization A or B, or you might want to capture different things from a patient encounter if it's a donor versus a recipient. So this is also very important for us to give the flexibility and the self-service tools to our customers to get to deliver exactly the attributes on the data. And then the registries that I mentioned are very data entry heavy still. We can do integrations out of the EMR system, but they're also still form-based. So you take the data model and you say, all right, you see the data model components over there on the right, and you say, all right, I'm going to build a form. I'm going to give it to them on an iPad in the doctor's office, and they can fill it out to 20 forms or the 20 attributes, and then the doctors will fill out the others during the appointment. So anyway, that's all I had as far as the kind of talking through the system of record, the technology, the compliance, pain in the ass, our path through to the solution, as well as a little bit of glimpse into the system. So we have about 5 minutes left. might get you guys out of here early. Are there any questions for me or for Will?
How do you deal with schema evolution on a topic? So if you're persisting these things for years, over time they have to evolve, I would assume.
So as I mentioned, the question was how do you evolve schema on a topic? So of the stream, you have these things happening over time, and you might have extra attributes show up. As I mentioned earlier, the workflows for auditors also need to be versioned, and that a couple of these ago, data models are versioned as well. So if you have an evolution to the messages coming in, like you switch from HL7 version 2.3 to 2.5, and there are extra attributes on the patient or on the encounter, we would add those to the data model. This is also versioned, and the system will look and say, probably even give you an option. Do I have to recompute all the materialized views based on these new attributes or not? Usually it's, if they're new, you don't have a problem. They just start flowing in, and you can just say, all right, the data model changes, the workflow will now execute, and you usually have warning that they're going to change or that you're going to change your schema. When it's a change to the schema, it's a little more interesting because you have to then decide, do I want to reprocess and recalculate all of my materialized views? The search engine has to be updated. The graph database has to be updated. And you might need all the compute power to essentially recompute those in the background and then do a hot swap. It's a difficult problem. Yep.
How do you handle GMP and GCP compliance?
GMP and GCP compliance.
Manufacturing.
I don't know as though we do. We don't have, so what specific manufacturing?
So, for like the clinical trials, manufacturing a drug for that trial that's monitored by federal.
Oh, so these are the FDA regulations? We're working much more closely with, we don't have, I mean, we do have US-based pharmas. We have BMS and Merck and maybe one other that I can't mention. But we're doing use cases right now on Alloy with IDMP, which is the European counterpart to exactly the legislation and the regulations you're talking about. And so this is essentially a master data management and serialization problem for us. And so we believe we have the building blocks, right here to handle all of that. Like it's kind of very abstract to move things into a search engine and to move things into a graph database. When you do it in a certain way that the auditors of the EU equivalent are looking for, there are 335 attributes that IDMP is looking for, and you have to trace. I mean, it's minute. I mean, when you change the rubber in the dropper of the medicine down the line after, like many years after distribution, and that starts killing people, that's one of the things that they would like to know and put a stop to instantly. So again, it's all the compounds and all of the materials in, like the bottle, and the dropper, the vial, the syringe, all of those go into, well, maybe not the syringe because it's separate from the drug, but all of those are captured in those attributes, which is why we tend to phrase it as a master data management problem. I don't think that answered your question because we don't have any active use cases in the US on those particular regulations. Sorry.
How do you know that events in the log are related? I mean, if you have different events that are related to the same patient, how do you relate them?
So how do you know if different events on the topic are related? Often, well, it depends on the source data. So oftentimes you get an MRN, which is a patient. In this case, you get a patient ID or a provider ID or something like that, and you can go ahead and match them and arrive at a key. Sometimes the upstream topic is very raw. and you'll go through a series of workflows, and maybe you don't put it into a materialized view, you put it into another stream, and you're doing matching on it, right? So you could have John Smith and Jonathan Smith, as I talked about earlier, not be matched up until you go ahead and have, put it in the graph database, and you run a matching algorithm that says, okay, I'm now 95% sure these two are the same. So one of those microservices up there says, or one of the apps and API calls says, these are the same, either link them or actually hard merge the records. So another message to merge goes back to the beginning of the log. And then you have workflow activities that go ahead and clean up the materialized views. Okay. We are out of time. Thank you very much.